Welcome to Stats Online. We are in lesson 2-4 and we're going to calculate correlation today. Please make sure that you have your graphing calculators out and ready. If you don't have it, you're going to need one. It's a requirement for the course, so please make sure that you get a graphing calculator. Okay, so you should be able to today calculate the correlation, and you should also be able to identify outliers and notice how they will influence correlation. Okay, so let's get started. Here is the formula. Are you freaking out? Don't freak out. Don't freak out. It's not bad. It's really not that bad at all. You want to know why? Because statisticians, we usually do not find these by hand. Now, I could have you find them by hand, and some teachers do, and there's definitely a lot of value in doing that. But for this lesson, I really want you to use the tools like a calculator, any software that you have. So if you have a different way, just contact me and let me know. But you should be able to interpret the results when we find correlation, which is even more important. And so no worries, but this is it. She's pretty, isn't she? I think she's gorgeous. I feel like we should do one. We should just do one. Not today though, but in the future, maybe. Let's do it. Okay, so first thing that I want you to do is that with your graphing calculator, you need to turn on the diagnostics. And to do that, you need to press the second button and then the 0 button, and you'll notice it says catalog above the 0. So then you're going to be in the catalog section in your calculator. You want to tab all the way down where you see diagnostics on. And then you need to hit enter until your calculator tells you that it is done. And then you are ready to move on. All right, step 2, you are going to enter the data. If you notice in this L1 and L2, the L1 are your X values and your L2 are your Y values. And these are the numbers that I want you to practice and type in with your calculator right now with me. So to do so, you are going to push the stat button, right, which is right below this delete button. Hit the stat button, and then you're going to hit 1 for edit, and then you're going to enter in the data like so, and when you are ready, we'll continue on. If you're not ready, this is going too fast, press pause, but I'm moving on. Okay. All right, step 3. We are going to now calculate. So you're going to then, after you type in your list of numbers, then you are going to push the stat button again, and then you're going to tab over to calc, and then you're going to tab down to 4 or press number 4 for Lin Reg. So this is what should come up on your calculator if you did it correctly. You have your y equals the ax plus b. Hey, that should look familiar, right? And we're going to be talking about this in the next couple of days. We're also going to be talking about r squared, but just pause for a minute. All I want you today is just to look at our r value. Our r value is 0.8018. Pretty cool. There it is. We know that the relationship between L1 and L2 that we entered into our calculator is pretty strong, and it is positive. All right. So let's go ahead, and I would like you to try this all on your own. Let's pause the video. Let's write down this table. I'd like you to tell me the correlation between your foot length and your height. Now, I want you to kind of think about it for a second. Your foot length, how long your foot is, and how tall you are. It's probably a pretty positive correlation, right? It would be really weird to have huge feet and be super short. I'm not saying it doesn't happen, because it happens, but it doesn't happen very often. How about that? And so I want you to expect something when you are calculating the correlation. I would be like, this should be positive, right? And it should be kind of strong, I would think. So please pause this video, type it in. Let's see how you do. All right. If you did this correctly, then you should have got a correlation of r equals 0. Nope. 0.8405. So you can round it to the nearest 100th. You can round it to the nearest thousandth percent, thousandth place, which is what I'm going to do, which is three decimals, or yeah, three parts, three numbers past the decimal. I need a coffee. Okay, so I'm going to say that our correlation is 0.841, which is the 1,000th place. All right, so let's go ahead and take a look at what an outlier does for our data and for our correlation. So take a look. You have the battery life and the cost of the battery. And so when we're looking at those, so the cost of the battery increases, we would expect that the battery life also increase, right? The more expensive the battery would be, then the battery life should be able to last a little bit longer. And then I notice that I like to kind of just eyeball or kind of like draw a line and say, well, most of the points are kind of following a linear pattern, not super strong whatsoever. And then I have these two little guys sitting over here. And those two are costing a lot of moolah and have very, very, very little battery life. So what is that going to do to our correlation? It's going to change it drastically. And they're so far off these two outliers are. They're going to cost a whole lot of money, and they barely last at all. That is going to take your positive correlation and turn it more towards zero, maybe even negative. Depends on these numbers here, and kind of if you were to put them in your calculator, if we had the actual number for each one of them off on a table, we can kind of see what happens. But when you notice that there are two outliers, and just ask yourself, man, those are definitely outliers, because 500 for like 2 battery life is crazy, way different. Then throw them out, right? Throw them out, because they're going to change the correlation dramatically. All right, so I would like you now, this is the last slide for today. I'd like you to spot the mistake. And we want to explain what is wrong. And so I really hope that you're taking good notes. I know sometimes maybe it feels to me like this is flying by. Like in my classroom, we'd pause, I'd make sure everyone writes this down. We talk about it, and I just don't have that with you guys. Okay, sorry, I'm off on my tangent here. Okay, so let's talk about it. There is a high correlation between the gender of American workers and their income. Think about it. High correlation between gender of American workers and their income. What's the mistake? Well, isn't gender categorical? Yeah, gender's categorical. So we're looking at scatter plots. We're talking about correlation R. We're talking about calculating the correlation, and we can't do that when we have a categorical variable. Gender of American workers, that is categorical. But income, quantitative. We can definitely work with that. But for scatter plots, no categorical. Nope, not for the correlation, no categorical. So that is the mistake. All right, number 2, we found a high correlation of our R equals 1.09 between SAT scores and the GPA of a sample of high school students. Can you spot the mistake? I hope you can. Our correlation is between -1 and 1. And 1.09 is too large, and it must be less than or equal to 1. And so it is too big. 0.09, that is not a true statement, and that cannot happen for a correlation. It cannot be greater than 1. All right. I hope you guys enjoyed today. I know, to me, it felt like it went really, really fast. I hope when you're organizing yourself at home and you're organizing your notes that you pause this video, you pause me a lot, and you write these things down, especially the steps in your calculator today on how to find the correlation. All right. Hope you guys are having a good day. Bye.